Hello everybody. Today we are going to solve Leetcode question 1352, product of the last k numbers. Design an algorithm that accepts a stream of integers and retrieves the product of the last k integers of that stream. We have to implement a class that initializes the object, has an add method that appends the integer nums to the stream, and getProduct returns the product of the last k numbers in the stream. You can assume that always the current list has at least k elements. Okay? The test cases are generated so that the product will always can fit inside a 32-bit integer. Okay, let's look at the examples. So uh, we initialize the product of numbers. We add. Um, so we add 30254. We initialize the product of numbers class, and after this we call the add method. So we need to have the add method, and we have get product method. Right? So we initialize the class, and then after we add 3, we add 0, 2, 5, 4. 0, 2, 5, 4. After this, we call getProduct2. So when we call getProduct2, we need to return the product of last two numbers, right? So at this stage, when we call getProduct2, we need to multiply the last two numbers and return the product of the last two numbers. This will be 20, which is what we are returning here. Then we call getProduct3, which will be the result of multiplying the last three numbers, right? So getProduct3 will be 5 into 4 into 2, which is 40. Is what is the result. Then when we call getProduct4, we get the result of the last four numbers. And now because there's a 0, the result will be 0. So getProduct of 4 will be 0. Then we add the number 8. So now we add the number 8 to the stream, and when we call getProduct2 again, now it will be the result of multiplying the last two numbers, and that will be 32, right? So at any given point of time, we have to keep track of the numbers that are added, and we have to multiply the last k numbers. So thinking of a solution, the constraints tell us that the size of the size of k will be in the range 1 to 4 into 10 to the power 4. So we can store them in an array, right? So we can create an array, and we can keep adding the elements, whatever the elements that are added, and store them in an array. And when we call the get product, we can multiply the last k digits and return the solution, right? The time complexity of that would be O of n space to keep track of the array, and to get the product it will take off k time because we go and multiply the last k numbers. Great. Okay, thinking if we can optimize it, since we only need the last k product, um, we can multiply and store the uh, product of those numbers, right? So something like a prefix product would work here. So for example, if we use the prefix product on this array, we will have a prefix product of this will be 3, 0, and then this will be 0 again, and rest all will be 0 because there's a 0. So what we can do now is, because we encounter a 0, we'll reset the product, right? So we'll start from like 0 again. We'll start from 1 again. So we'll take this number after 0, whatever is there, we'll assume that 0 is not present, and we'll continue creating the prefix product as it was. So then this will be 2. 2 times 5 is 10. Then 10 times 4 is 40. Then uh, 40 times 8 is. Now, if we take a look at the calls, like for example, let's take the last call after we add 8. So when we need the prefix product of the last two numbers, we will take the product of the last, we will take the final product that we have, and we will go two places back and divide this product by this product. So when we do that, we will get the product we have from 4 till 8, right? The product till now is stored here, and the product before these numbers were multiplied together is stored at this place, right? I can change the color. So the product till now, after multiplying all the numbers, is stored at this place, right? At this index, and the product before multiplying these numbers is stored here. So to find the product of these last k numbers, we can just divide the product that we have now and the product before k numbers, right? So 320 divided by 10, 32 is what the result is. So if we use something like this, uh, the time complexity will reduce from O of k till to O of 1 for the get product function. The add method will always take O of n time and space because there are n numbers that are being added. The get product will reduce from O of k to O of 1, right? Because we are now constantly keeping track of the product and we just have to divide and return the result. Now thinking of some more optimization. So since we encounter a 0, right, anything before this will always be a 0, right? Right. For example, if we get the product of the last 5 digits, right? So 8 into 4 into 5 into 2 into 0. So because there is a 0, the result is 0. And if we do the same thing, get the product of the last 6 numbers, because there is a 0, the result will always be a 0, right? So we can uh, reduce the size of the array, right? We can keep track of array from here because there is a 0, and we can return 0 if the k value of k is ever greater than the length of the array, right? We do not have to keep a track of elements before a 0 comes in. As soon as we encounter a 0, we can reset the array and start fresh from there. Make sense? Solution. So we need to have an array to store the numbers. So let's initialize a variable to store the numbers, and we initialize it by having the already calculated product to be 1, right? Initial product to be 1, right? So here in the add method, when we encounter a 0, we have to reset this array, and when it is not a 0, we can just keep on adding the number. So there are two conditions: if num equals 0 and else. If the number is 0, the prefix product array is reset, right? Otherwise, we have to add a number to this array. Self dot prefix product dot append number times self dot prefix product minus 1. right? So we take the last number in the array, we multiply it by num, and we add it to the array, right? And this is all that this method will do. And get product. So in get product, we have to, so if the value of k is within the constraints, we can return the product, the division of the product at the last location by the division um, divided by the product of the product of the number at the last position minus k, right? So with this we get the position of the last number minus k elements, and this is the position of the last element. Once we divide them, we get the product. This is our running. Submit it. So we initialize a list which has initially the prefix product 1. So when the number is 0, uh, we initialize it, and otherwise we add a number to the prefix product array. And when we need to get the product, if the value for the get product, if we know if the value of k is greater than or equal to the length of the array, then we know there was a 0. That is why the array was reduced, right? So we can return 0, and in the other case we just have to return the division of the product at the last location by the product at the last location minus k. Thank you.